After completion of design of a doubly reinforced slab, not a doubly reinforced, a two-way slab, then the part is the diagram. Let us see that. So first, by knowing the external width, total outer width of the slab, and by knowing the outer length of the slab, the first we have to draw the rectangular box, which shows the external dimensions of the slab. Clear? Now next part is these vertical lines, not vertical, all these are horizontal only, but this is the line. This is the bar which is traveling along longer span, and these are designed as main bars along longer direction in the mid strip అని డిజైన్ చేసి ఉంటాం, which is with respect to M U Y. With respect to MUY, whatever the steel we have calculated, that is this one. Okay, these three bars, this one and this one and this one, all the three bars. అక్కడ త్రీ ఏ ఉంటాయా అంటే త్రీ కాదు మా, ఇంకా చాలా ఉంటాయి కంటిన్యూస్గా. అట్ ఎవ్రీ 220 mm సెంటర్ టు సెంటర్ డిస్టెన్స్ దెర్ విల్ బి వన్ బార్. ఓకే, బట్ ఓన్లీ త్రీ బార్స్ ఆర్ మెన్షన్. ఎక్కువ అన్ని మెన్షన్ చేస్తే ఇదంతా క్లమ్జీ అయిపోతుంది కాబట్టి ఓన్లీ త్రీ బార్స్ ఆర్ మెన్షన్. ఇన్ దట్ alternate bars are bent up. What do you mean by that? Here in this diagram you can see some dotted lines here, here, all these dotted lines that represent the bars at the top of the slab. Top of the slab lo unnavi dotted lines, bottom of the slab lo unnavi solid lines. Okay, the rods which are provided at the bottom are represented with a solid line. The bars which are at the top is represented with a dotted line. Okay, now here these three bars are the longitudinal bars which are provided in the middle strip, which are 8 mm diameter at the rate of 220 mm center to center. Now one thing is over. And so let me share the file. So these are the bars which are running along longer span. Next, coming to the bars which are running along a shorter span. These three, 1, 2, and 3. These are the three bars, 1, 2, 3. And these are the bars which are running along short span in the middle strip. Okay. And what are the details of that? 8 mm diameter bars at the rate of Srinivas 270 mm center to center. All these are designed in the procedure itself. Okay, now coming to the main position where we have to provide edge strip, where we have to provide middle strip, that we have already known. Along shorter span it will be shorter span by 8. Okay, and along longer span it will be longer span by 8. That's it. Already in the code I have shown how much width of edge strip will be there and how much width of middle strip will be there. So on either side, if you provide for a distance of 500 mm, from here to here it is 500, and from here to here it is 500, and the remaining portion is called middle strip. Okay, and in the same way this is 440 mm, ఎలా వచ్చింది ఇది 3500 by 8, and this is also 440, and whatever the portion left over in between these two, that is called middle strip. Okay, and this is the plan. And let me draw the cross section. The cross section showing cutting along the shorter span. Okay, and in the procedure itself I have clearly said always shorter span steel will go at bottom, then over that longer span steel will run. Okay, so first let us assume this is the first bar. Okay, this is the first bar. It travels, see here we have dotted line. Dotted line means it started in the top up to certain zone, then enters into bottom. This bottom point is from here it will become a solid line. Okay, it runs in the bottom only. Okay, next coming to second bar. See, second bar is represented with solid line here. Solid line ante meaning it is traveling in the bottom only. It is traveling in bottom. ఎక్కడ వరకు సాలిడ్ లైన్ ఉంది? ఈ పాయింట్ వరకు ఉంది. మళ్ళీ డాటెడ్ లైన్, దట్ మీన్స్ ఇట్ ఎంటర్స్ ఇన్ టు టాప్ నౌ. ఓకే, దాని తర్వాత బార్ starts at top, enters in bottom. Next bar starts in the bottom, enters into top. Like that, the provision of steel will be there. And all these are x direction steel, that is shorter direction steel. Then after that, y direction steel. Okay, y direction steel, if you look from this, it will be like a dot. No, you cannot see the length of the bar, you can see only a dot. So all these dots what you can see in the section is the main steel. Okay, main steel along longer span. All these are represented here. See here, this line is 8 mm at the rate 180 and these dots are 8 mm at the rate 220. But see here at the end, ఈ ఎండ్ వచ్చేది ఎడ్జ్ స్ట్రిప్ కదా, ఎడ్జ్ స్ట్రిప్ డీటెయిల్స్ వేరే, దట్ ఈస్ 8 mm at the rate of 270 mm center to center. Okay, and all the dimensions of the slab, 150 mm thick, length of the slab, width of the support, everything is mentioned in clear. Once check this detailed diagram after you receive the material. Already I have sent the material to your CR and GR, collect from them, and after the class once check the drawings. Okay, next coming to second problem, which is also a two-way slab design. So once let us understand the question first. The first problem is a two-way slab which is simply supported. Okay, it's not a restrained slab. The corners of the slabs are free to lift. That is what we have done in the previous problem. But this, let us see. Design a floor slab for a hall 4 meters by 5 meters. So Ly is 5, Lx is 4. To carry a live load of 3 kilonewton per meter square and floor finish of 1 kilonewton per meter square. Loads are given. Now the condition of the slab. The slab is continuous over two adjacent walls of the hull. The slab is continuous over two adjacent walls of the hull. This is the condition. We'll discuss in detail. Next, walls are 300 mm wide. Concrete grade is M20 and steel grade is Fe4 and 5. Okay. Here, as it is a continuous slab, just a minute. As this is a continuous slab, it will be treated as restrained. Okay, so for restrained slab, the difference in procedure with respect to simply supported two-way slab, the change in procedure, one step will be added, which is torsion reinforcement we have to provide. In case of restrained slabs, torsion reinforcement has to be provided. That is the first change. Okay, and how much torsion steel we have to provide, everything is already discussed, and that will continue in the problem itself. And one more change in the design procedure is, in case of simply supported two-way slab, we have determined only two moments. One is mx, another one is my. This is along short span, this is along long span. But in case of restrained slabs, we will get total 4 moments. One is mx positive, another one is mx negative, and next my positive, my negative. These are the 4 moments we will get. That's it. These are the changes we will get in this problem. One is torsion design step will be added, and in addition to 2 reinforcement, we have to calculate 4 reinforcement in total. Okay, so the lengthy problem, it will become somewhat lengthy compared to simply supported slab. Okay, so let us understand step by step, and remaining 80% of the procedure is same. So let us just discuss in detail. And where we will provide all these reinforcement, let us once use this 125. మా సెషన్ రికార్డులో ఉంది అని చెప్పాను, ఊరికే కోతి పనులు అన్నీ చేయకండి. అనవసరంగా కోపం తెప్పికండి. ఈ వీడియోస్ మీ ఇంట్లో వాళ్ళ ముందర చూపిస్తాం. మీ ఇంట్లో వాళ్ళకి పిలిపించి క్లాస్ చెప్పేటప్పుడు ఇలాంటి డిస్టర్బెన్సెస్ క్రియేట్ చేస్తున్నారని వాళ్ళ ముందరే వీడియో ఆన్ చేసి చూపిస్తాం. అనవసరంగా ఊరికే లేనిపోని తలనొప్పులు తెచ్చుకోకండి. మీకు ఇంట్రెస్ట్ లేకపోతే ఫస్ట్ క్లాస్ నుంచి బయట వెళ్ళిపోండి. Okay, in a two-way slab, mx positive will be provided along short span in the middle. Okay, mx negative, that is also provided along short span at the support. Okay, and my positive, y means long span, right? So along long span in the middle portion we will provide my positive, and along long span near the support we will provide my negative. Let me write for ease of understanding. Mx negative here and mx positive in the middle. In the same way, my positive in the middle along y direction and my negative along y direction in the support. Okay, these are all the different four types of steels that we have to design and provide separately. ఓకే, బట్ ఇక్కడ ఒక చిన్న టిప్ ఉంది. ప్రాబ్లం ఎగ్జామినేషన్లో కూడా టైంని రెడ్యూస్ చేసుకునే టిప్ ఈ ప్రాబ్లంలోనే వస్తుంది. ఐ విల్ టెల్ యూ ఇన్ డీటెయిల్ లేటర్. వీ కెన్ అవాయిడ్ డూయింగ్ దీస్ క్యాలిక్యులేషన్స్. అన్ని 4 అవసరంలా కొన్ని అవాయిడ్ చేయొచ్చు. ఓకే, అది ఎలా ఏంటి అని ఆ స్టెప్ వచ్చినప్పుడు చెప్తాను. రైట్, కమింగ్ టు ద ఫస్ట్ స్టెప్, క్లాసిఫికేషన్ ఆఫ్ స్లాబ్స్. Ly by Lx, which is 5 by 4, 1.25, and as it is less than 2, it is designed as a two-way slab, that we know. As it is less than 2, it is two-way slab. And assumption of thickness of slab, Lx by 28, we got 142 point something, right? 142.9 mm. Just be online. Sir, చెప్పండి sir. Reimbursement, sir. So here, based on this ratio, we got 142 mm. So round up, we have taken 150 mm. Okay, and if effective depth is 120, how to find overall depth? Add effective cover. Okay, I have taken 25 mm as effective cover. So finally, overall depth is something around 175 mm. Remember, effective depth is 150 and overall depth is 175 mm. Okay, next. Third step, effective span along x direction and along y direction. What is the formula? Say, clear span plus small d. Clear span plus small d. Clear span is 4000 given in the question, and 150 is small d, which is equal to 4.15 meter. In the same way, along y direction, 5000 plus 150, which is 5.15 meter. Okay, and after knowing effective spans, let us calculate the final value of Ly by Lx, which is 1.24. Okay, now why this value is important? Only based on this you will get alpha x positive, alpha x negative, alpha y positive, alpha y negative. All these things you will get based on this value only. Okay, now the next step, which is loads per meter width of slab. How to do it? In the question, 2 loads are directly given. One is live load, another one is floor finish. These two are directly given. In addition to that, we have self-weight of slab, right? How to find self-weight of slab? Thickness, overall thickness of slab multiplied by the unit weight. So just multiply both. We got 4.375 kilonewton per meter square. Okay. Next, by adding of all these three, we got a total working load of 8.375. And how to find a factored load? Multiply with factor of safety, which is 1.5. You will get 12.56 kilonewton per meter square. That is loads per total load per meter length of the slab. Now next step, calculation of bending moment. Actually I have written shear force, but that is not required. Why? Because we are not doing shear check. Okay, bending moments and shear force, let us calculate. Okay, that is not a big one, so let us calculate both bending moments and shear forces. And let me show you the code first. Why? Because for this case, we need to understand first, identify which case it is. This is not a simply supported. In the question, they say some two adjacent edges are continuous, right? Let us check which case it is. So annexure D, right? So annexure D, that is for two-way slabs. Remember this. And formulas are this one. For restrained slabs, the formulas are mx my. Formulas are same, but if you just substitute alpha x positive, you will get mx positive. If you substitute alpha x negative, you will get mx negative. In the same way, we'll get two moments along y direction also. Now, this is the table. Bending coefficients for panel subjected to different end conditions. Okay. మరి ఇక్కడ కార్నర్స్ హెల్డ్ డౌనా, కార్నర్స్ నాట్ హెల్డ్ డౌనా అని క్వశ్చన్లో ఇవ్వలేదు. ఒకసారి బాగా అబ్జర్వ్ చేయండి. ద స్లాబ్ ఈస్ కంటిన్యూస్ ఓవర్ టూ అడ్జసెంట్ వాల్స్ అని చెప్పారు. వాట్ యూ మీన్ బై దట్? వెన్ ఎవర్ యూ హ్యావ్ ఎ కంటిన్యూటీ, that means it is restricted for lifting. In the theory part I have explained this one. Whenever you have discontinuity, there is a chance of lifting of corners. But whenever we have continuation of a slab, that corner is restricted for lifting, which is called as restrained slabs. Okay, and restrained slabs లో ఇక్కడ మనకు చూడండి 9 cases ఉన్నాయి. ఈ 9 cases లో మనకి ఇచ్చిన కేసు ఏంటో చూడండి ఒకసారి. The slab is continuous over two adjacent walls. First let me draw a rectangular slab. In that, let us assume 1, 2, 3, 4. These are the edges, 4 edges. And in the question they said that two adjacent edges continuous. Let us assume 1 and 2. These two are continuous. And each side slab undi, each side slab undi. Okay. On these two sides there is a slab. But these two adjacent edges are discontinuous. That means these two edges are discontinuous. The main concept is the two adjacent edges are continuous. That is what they have given. Another meaning of it is two adjacent edges are discontinuous. Let us check the case. Now in this, the first one is interior panel. Interior panel ante all the edges are continuous. Anni chuttupakala anni continuous unte interior panel antam. Next one is one short edge discontinuous, one long edge discontinuous. Everything is explained in the previous sessions. You can see that in the videos also if you required. And the fourth case, if you observe fourth case, two adjacent edges discontinuous. That is what we need. So this is the case. And for that case, I have written here, as the slab is continuous over two adjacent walls, it belongs to case 4 of table number 26. This is table number 26, which is belongs to case number 4. And మీకు ఎగ్జామినేషన్లో కానీ లేదా ఫర్దర్ ఇంకొన్ని ప్రాబ్లమ్స్లో కానీ ఎప్పుడు కేస్ 4 వస్తుంది అంటే నో, దట్ మే బీ ఎనీ ఆఫ్ దిస్ 9 cases, ఏదన్నా అవ్వచ్చు. ఫస్ట్ యూ హ్యావ్ టు ఐడెంటిఫై ఇట్. ఓకే. Now, from this table, these are all alpha x values from here to here. These are all alpha x values. And the last column, only this last column is alpha y values. For obtaining alpha x value, what are the things required? Ly by Lx ratios. All these are Ly by Lx ratios. And for our case, Ly by Lx ratio is 1.24. And 1.24 directly is not there. 1.2 is there, 1.3 is there. From that we need to do interpolation. Okay, now just understand, from column 5 and column 6 we have to take the values and do interpolation. And for case number 4, అండ్ ఇక్కడ ఒకసారి చూడండి, కేస్ నెంబర్ 4లో 2 వాల్యూస్ ఉన్నాయి, 0.06 ఒకటి, 0.045 ఒకటి. ఏది నెగిటివ్, ఏది పాజిటివ్? సో see here, let me draw the first row, all these first row values up to here, these are alpha x negative values. Okay, within the box all these are alpha x. See at the top you have heading alpha x negative values. Okay, and at the bottom, whenever meeting ends you just rejoin for the new session. Okay, within a second you just rejoin, I will start immediately, you just rejoin. And at the bottom, whatever the values you have at the bottom, all these are alpha x positive values. Okay, positive values. Now by doing interpolation, and let you join for the next session.